Hello and welcome to another exam paper walkthrough. Doing a slightly different strategy in this exam. It is useful for your exams, but today I'm going to be looking at getting to know the formula sheet. This is predominantly aimed at foundation, but it is useful for higher as well. This is a copy of the foundation sheet. It was recently decided back in January that you would have an exam aid this year as well. And this PowerPoint was originally created by www.justmaths.co.uk. Really good revision website. If you find this useful, please subscribe if you like. Okay, so first of all, the formula sheet. This is designed to get the most out of them. So Edexcel have produced this. This is the May to June 2024 assessment window. And they've written a special one. Well, I looked at how much of this had changed from the previous one back in 2022, and actually there's no changes at all. So it's the exact same exam aid that they've used for the past 2 years. No changes have been made. Anybody watching this video and looking for higher, the only additional elements to the higher over the foundation is the quadratic formula, and then we've got the advanced trig formulas. Everything else is exactly the same. There's just those additional aspects for quadratic formula and then advanced trig. Okay, so a lot of these are useful, provided you understand what they are telling you, what you're given by the information. Some of them aren't particularly useful though. You may not need to use all of them in every exam, and you're very rarely going to need to use all of them. Some of them never get used as the topics do not appear on the paper on a regular basis, and some we have done in different methods. Two in particular we've done in different methods. So the first section is perimeter, area and volume, and you're given the area of a trapezium. That is a very useful one. Area of a trapezium comes up around 75% of the time, so it is a very useful formula. The volume of a prism, the area of the cross-section times by the length. That also works for cylinders. Area of the cross-section, so the uniform face, times by the length of the shape. So that one is useful. And then the other two are definitely useful. The circumference of a circle is equal to 2 pi r, which is equal to pi d. I would never write two equal signs on the same line, but that is still a very useful formula. It's two versions of the formula. And then the area of a circle, pi r squared, again, that will be a useful one for you. The next section of the exam aid is Pythagoras' theorem and trigonometry. Very common aspect that does come up. So the first one, a squared plus b squared equals c squared. Provided it's labelled like this, I tend to try and remember that the square of the hypotenuse is equal to the square of the other two sides added together. And then you've got your trig ratios. Sine A is equal to A over C. Sine A, cos A is equal to B over C. Tan A is equal to A over B. That's not a very common way of writing them. So the Pythagoras theorem is definitely useful. The trig, we tend to use that tan A is equal to opposite over adjacent. And then the other versions, so we use these three versions. But they are really the same thing. They are really the same thing. So that is a useful formula. That is a useful formula. The other two, compound interest written in that way. Compound interest written in that way is strictly speaking correct. However, I would never, and most teachers would never teach it using that formula. So we've done compound interest, but we've done it in a very different way. So I would say that one isn't going to be very helpful to you guys. And then the probability one. This probability formula just causes confusion. We have done a lot of the probability, but that's not going to be a useful one in our context. So we're not going to use that. Okay. So that's not to say that they can't be used. It's just we've done a different method. If you can't remember that method and you want to use that formula, you can. Those formulas you can. But personally speaking, I would encourage you to use a slightly different version. So I'm going to give you a sheet where we've got a series of questions that all rely on the formulas just to have a little bit of a practice of using them. Okay, so the first half of this sheet is all based around the perimeter, area and volume formulas. So the first one, this is actually a trapezium. The badge is going to be a trapezium. We haven't been given the full dimensions of the badge, but we can work them out fairly easily. If this length here is 6, this length here must be 4. So using the formula from the formula sheet, the area is going to be equal to a half of A plus B times by H. well, it does say h, but I'm just going to put times by h. So it's going to become, substituting my values, a half of 6 plus 4 times by 3. So 10, half of 10 is 5. 5 times 3 is 15. So we're looking at 15 centimeters squared. Nice and straightforward. I'm actually going to do them out of order for the specific reason of I'm going to follow I'm going to follow the order of the formula sheet. The next formula is volume of a prism. This is the formula. This is the volume of a prism one. So the volume of a prism is equal to the area of the cross section. So I'm going to call it ACS for area of cross section times by the height. The cross section is a triangle. The area of a triangle is a half base times height. Not given to you, but we should be able to remember that one. And arguably, just being brutally honest, you can use a formula for the area of a trapezium and say that your A is 0 and your B is 12. That would still work. The base, so it's going to be a half of the base, which is 12, times by 5. I wouldn't do personally 12 times 5 and then halve it. I would halve my 12 to get 6 and then do 6 times 5. 6 times 5 would give me 30. Right, so I've got the area of the cross section. So my volume of the prism is going to be that area times by the height times by 10. So that's going to be 300 centimeters cubed because it's a volume. Right, the next one then, we've got, from the formula sheet, it says the circumference is next. Which one of these two questions is the circumference? It's going to be this one. So you're told a circle has a diameter, so you're given the formula with the diameter. Work out the circumference, giving you answer to 3 significant figures. So we will need to calculate for this, even though we're warming up for a foundation paper. A non-calculator paper. So we've got a formula for the circumference. I want the version involving the diameter, so the circumference is equal to pi d. So it's going to be pi times by 140. And then I can just go to my calculator to get my decimal version of that. So while I'm presenting in PowerPoint, my calculator can be a bit awkward. As soon as I tap back on the PowerPoint, I lose my calculator. So just bear that in mind. So shift pi times by 140 gives us, as a decimal, 439.822. So to 3 significant figures, that would be 400. I should write that down to more degrees of accuracy than needed. 439.82. 439.82. ... More accurate than I needed. 3 significant figures. That's the third significant figure. So that would actually be 440 centimeters as a length. Okay, and then the final one on this section, a circle has a radius of 5.8. So radius 5.8, work out the area, correct to 1 decimal place. So the formula for the area is given to you on the formula sheet. Area is equal to pi r squared. And then, so area is going to be equal to pi times by 5.8 squared, which is going to be equal to, going to my calculator to get the decimalized version. So shift pi, I've already got pi in my calculator screen, so I'm just using the replay button to make it slightly quicker for myself. 5 times by 5.8 squared in terms of pi. So if you're asked for it in terms of pi, that's what you write down as a decimal. 105.683. 105.683. ... So I haven't rounded, and then to 1 decimal place, then that's going to be 105.7 centimeters squared because it's an area. So I'm just going to say this on the video. So somebody in my class has just asked how many marks would each of these questions be. And I'm just talking about, technically speaking, that would be quite difficult for me to say because, for example, this one, area of a circle is typically like a 2-mark question. Arguably, if it was a you didn't have the formula A, then you could argue a 3-mark. Typically, it would be a 2-mark question, one for the method and then one for the answer. But because this is set to one decimal place and doesn't have a unit in it, there could be an additional mark for rounding and there could be an additional mark for the unit. So it could be, in theory, it's unlikely, but it could be a 4-mark question if the exam board decided. Okay, so the second half of the sheet is focusing on, the first 3 are on Pythagoras' theorem and trigonometry. It's right-angle triangle straight away. Thought process whenever you get a right-angle triangle is there will be 3 bits of information that are linked within the question. Either the 3 sides, in which case it will be Pythag, or 2 sides and an angle, in which case it will be trig. One of the 3 is an unknown that you will have to work out. Let's just work out, this is asking us to work out the length here, so if I call this length x, so 3 sides, so it's got to be a Pythag question. See, this is actually working out a shorter side. I tend to say that a shorter side squared is going to be equal to the hypotenuse squared minus the other side squared. Although if you want to follow the formula, strictly speaking, what you would end up with, and laying it out like the formula, that we would end up with 13 squared is equal to 6 squared plus x squared, and then you would need to rearrange it to get to this point, but that's fine. I would then go straight to my calculator. So on my calculator I would work out that value, so 13 squared minus 6 squared. I would write down what that evaluates to, so x squared is 133, and then I'd just go straight to the value for x. Now, strictly, so square root of the answer, and we want 11.5325. So that's going to be equal to 3 significant figures. X would be equal to 11.5 centimeters. So the next question then is bringing in, it says work out the size of the angle marked RPQ. So RPQ is going to be this angle here. So typically speaking, and I don't want to cause any confusion, but typically speaking we use a 0, well, it's like a 0 with a line through the center. It's pronounced as theta, it's a Greek letter. It represents an angle that we don't know yet. So again, this question involves 2 sides and an angle. So that tells me automatically it's going to be a trig question. For trig questions, I do them in a fairly standard method. I would start by labeling the 2 sides that I'm working with in the question. So this is the hypotenuse, and this is next to the angle, so it would be the adjacent. Only one of my trig ratios has a C and an A in it, and that is the cos ratio. C is equal to A over H. So that means that then cos of the angle is going to be equal to the adjacent side divided by the hypotenuse. And I would type this into my calculator. Well, I'll cos to the minus 1 because we want the inverse to find the angle, and then I would type it in. Then I would type it in as it appeared, 17 over 25. So that's the point that I will go to my calculator. So I'm looking at shift cos, and then we're putting 17 over 25. That gives me 47.1563. So I'm going to go 47.1563, 47.1563. So to 1 decimal place, that's going to be equal. Not quite sure what happened there. So cos to the minus 1, 17 over 25, which is going to be equal to, and then I've got it on my calculator, 47. So to 1 decimal place, that's going to be 47.2 degrees. Okay, the next one is a bit, I'm imagining is a bit of both. Looking at it, diagram shows a quadrilateral, so 4-sided shape, ABCD. AB is 16, which is shown. AD is 12, which is shown. Angle BCD is 40, which is shown. The angles ADB and CBD are 90 degrees, shown. Calculate the length of CD. So I want to calculate this length here. I'm giving your answer correct to 3 significant figures. Okay, so I'm going to have to work this length out, I need this length here. So I'm going to call that Y for now. So this is Pythag followed by Trig. Because I've got a right angle triangle here where I've got one unknown side, so 3 sides, Pythag. Again, it's the shorter one, so y squared is going to be equal to 16 squared minus 12 squared, which is going to give me as a value for x, for y, sorry. 16 squared minus 12 squared is going to be equal to 112, so 112. So I'm going to leave it like that for now because I want the exact value here. Now, if I change pen colour just to make this clear, now I can use trig. This side would be the hypotenuse, this side would be the opposite. And I want to work out the hypotenuse this time. So if my trig ratio is SOH, so sine is equal to opposite over hypotenuse, and I want to work out the hypotenuse is going to be equal to O over S. So x is going to be equal to the y divided by sine of 40. So that's the point where I would go to my calculator. I've got to do a couple of steps. I need to do the square root of y first of all, square root my answer. So that would be 4 root 7, but I don't really need to write that down, but I want to divide that by sine of 40. So I've done no rounding yet. So this is the first point of rounding, so I'm not going to have brought in a rounding error. So 16.464. So to 3 significant figures, dot, dot, dot. So to 3 significant figures, we're looking at 16.5 centimeters. Okay, the next question, to be fair, I love this as a resource. I don't really think that this is the question to really show the probability formula, so I've included an extra one after this. So there are yellow disc, red disc, blah, 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 blah. The table shows the probability that somebody takes a red, blah, blah, blah. Work out the probability that it will be a yellow disc. So it's just working out this missing probability. So I want to work out what these 3 add up to start with. So these 3 would add up to 0.4, 0.65, 0.7, 0.8, 0.8. So that's got to be 0.2. The other 2 are referring to the compound interest. So you could, in theory, use the compound interest formula given to you in the formula book, where P would be the investment amount, R would be... Oh, sorry, work out the probability. Yeah, that's the probability, 0.2. The next one is going on to the compound interest. You could use, that would be P, that would be R, and that would be N. And you could use the formula. What we tend to have taught you, though, is that the total money, the total is equal to the initial investment times by a 2.5% compound interest as a multiplier is a multiplier of 1.035. So we would just go times by 1.035 to the power 2. And then for the second one, same process. You could use the compound interest formula, but again, I wouldn't bother. I would say that 3.5% interest, we've just said, is a multiplier of 1.035. So my total in the account would be 1,200 times by 1. Yeah, I was just double checking, trying to read the question while writing, to the power of 3. And you can use your calculator to put those values in fairly easily. I'll do them both quickly now. I wasn't going to bother, but so the first one we said was, for some reason my writing keeps disappearing while I'm trying to talk. So I said it was 12,000 times by 1.035 squared. So my total in the account for that one is 1,285. I'm just going to grab a whiteboard pen. I'll put this answer in a minute. 1285.47, just because as soon as I tap on PowerPoint, my calculator goes. My other one, and I've typed the wrong value in there, sorry. That was a 5, not a 2. So my first value should have been as a decimal 1606.8375. And then for the second one, I need to change the 15,000 to a 12,000. And I need to change the power to a 3. So 1330.46145. So my two values then for this one, to the value in the investment, I'm going to go 1370. No, that's the wrong one. And on this one, I'm going to go 1370.46 pounds. On this one, I'm going to go 1370, and on this one 1606.83. And some of that writing disappeared, I'm afraid. But just to talk a bit more literally about the probability one. So this is a question where you could use that probability formula. So if I said the probability of a number being even, we've got 1, 2, 3, 4 even numbers, so it would be 4 out of 8 or a half. The probability of it being prime, would be, we've got 1, 2, 3, 4, 5 prime numbers. So if I wanted to work out, and the number of prime and even numbers is 1 over 5. So prime and even is 1 over 5. 1 over 8, because we've only got one even prime number. So the probability of it being even or prime, using that formula, it would be the probability of it being even plus the probability of it being prime minus the probability of it being even and probability of it being prime and even. So in effect, I'm going to write these all as 8 just because it's easier. Probability of it being even 4 over 8, probability of it being prime 5 over 8. The probability of it being even, prime or even, is 1 over 8. 1, 2, 3. Okay, so the probability of it being even or prime would be I've made a mistake somewhere on this. I'm just scanning it to try and work out where. Evens, I've got 1, 2, 3, 4. Primes, I've got 1. There we go. I've messed up with my prime numbers. 1, 2, 3, 4 prime numbers, not 5. So that's going to be equal to 7 over 8. The typical way we teach that though, is to view it in terms of a Venn diagram. So the numbers, where the numbers would go in this Venn diagram, if I had one for even and one for prime. So one would go outside, 2 would be even and prime, 3 would be prime, 4 would be even, 5 would be prime, 6 would be even, 7 would be prime, 8 would be even. So the probability of it being even or prime would be the union. So 1, 2, 3, 4, 5, 6, 7. 7 over 8. That's the way we tend to do it. That's the way we tend to look at it rather than that long formula. But that's where the formula comes from. There. Okay, so that brings us to the end of the getting to know the formula sheet. So again, this was originally created by Just Maths. Really good website. They do a lot of revision. They work very closely with the exam board as well. Really nice company. So thank them for producing this. And if you found this video useful, please do subscribe if you like.